Hello and welcome. This is the Cybersecurity and Information Systems Information Analysis Center, or CSIAC, and today we are following up on previously popular CS Digest articles. Nearly every CS Digest contains a handful of articles that fall into the realm of critical infrastructure. Many of the headlines are quite daunting and paint a very grim picture of the state of the industry. Additionally, some of our most popular articles of the past few months have been from this section. But why? Why do we continue to see articles again and again in this sector? By definition, these are some of the most valuable locations to our society. Why do they not have the best defenses? In this follow-up, we'll examine some of the primary deficiencies inherent in critical infrastructure, as well as investigate how the industries are trying to combat the vulnerabilities. Perhaps the best place to start is with the underlying fundamental technology that the industry uses. SCADA equipment, industrial control systems, human-machine interfaces, building management systems, PLCs, and a plethora of other industry-specific control equipment makes up a majority of the technology. And while critical infrastructure sites often have a network of typical servers, desktops, and laptops, it is important to realize that the rest of this equipment is fundamentally different than the average home or office computer. From a cybersecurity perspective, these fundamental differences are the root of all the major incidents we read about regarding critical infrastructure. Even some of the most basic computer techniques we are all aware of, such as, well, did you try turning it off and back on again, really don't work in this field. Much of this equipment needs a near 100% uptime, and restarting the equipment would be catastrophic to the process it is performing. In regards to software, this translates into a major problem for a pillar of cybersecurity, patches and updates. Even well-written software needs maintenance in the field, especially because the focus of this software is the functionality and safety of the system it is running, not the security. The code was simply never designed to be picked apart by an attacker. The end result is that the timely updates and patches in the critical infrastructure realm are extremely challenging compared to your average desktop. In addition, this problem is amplified when you consider the life expectancy of the technology. An average desktop is typically replaced every 3 to 5 years, and operating systems are released at about the same frequency. In critical infrastructure, the technology might be expected to operate for decades. So even if there is some downtime for updates, after a decade the technology might not even be supported anymore. Critical infrastructure industries also have an additional layer of complexity with regards to warranties and certifications. A typical desktop warranty might be for a year, perhaps extended to 3, which is suitable for the device's expected life cycle. Typically, during this time frame, there are many changes you can make to your computer that will void the warranty. Critical infrastructure also relies on vendor support for their equipment, but again, the time frame is significantly longer. Often, because the stakes are so high, vendors do not allow any changes to the software or hardware without prior approval. Remember, it was previously mentioned that the vendors build the equipment to operate consistently and safely, not necessarily securely. Therefore, any change, even if it is to improve the security, has to be proven not to affect the safety of operation, which takes time and resources. A very similar concept exists with sites that require either government certification or vendor certification. The cost or risk of a security change to the safe operation of the equipment has proven to be too great in many cases. Another important consideration for the state of critical infrastructure security is remote access. In the age of the internet and global connectivity, many critical infrastructure sites have made secluded locations accessible over the internet for quick response and convenience. Additionally, many vendors do service SCADA or ICS equipment on a regular basis. However, to respond faster and save on costs, vendors might require remote access to their equipment. So who is keeping track of all the different remote access points a facility might have? Have they all been secured? While isolated SCADA software might arguably be just fine without any specific cybersecurity controls, the moment it becomes reachable via the internet, that is simply no longer the case. Anyone who has ever browsed Shodan will inevitably encounter critical infrastructure technology. The result is a single large plant that has numerous remote static locations serviced by a variety of vendors ends up with quite a large attack surface. Again, understanding that when safety is the priority, security concepts such as changing default passwords, for example, are often overlooked for fear of an engineer not having access in the crucial seconds of a crisis that access is required. A final challenge we'll consider for critical infrastructure security is that of prototypes and custom solutions. A typical corporate network environment, most desktops run the same software, regardless of whether the offices are in New York, DC, or LA. However, with critical infrastructure, this is often not the case. When a plant is built, numerous factors determine how it operates, such as size, capital investment, available workforce, time frame, what technology is available, and the purpose, to name a few. This can reduce the learning benefit between sites, as well as reduce the likelihood that there will be a single deployable solution across multiple sites. Yes, critical infrastructure often has several layers of redundancy, but that does not mean it has been addressed in the same manner each time. And again, redundancy often is to ensure consistent and safe operation, not necessarily secure operation. So is this the end? Will headlines continue to highlight more and more breaches? Well, because of the scale of this problem, unfortunately this trend will likely continue for a while. However, that doesn't mean that organizations have no chance of securing their infrastructure. Let's understand critical infrastructure defense from an interesting and unlikely source. Rob Joyce, head of TAO, or Tailored Access Operations at the NSA. The organization specializes in exploiting foreign networks to provide valuable foreign intelligence, and Rob Joyce recently delivered a presentation on what organizations can do to defend themselves against even the most advanced or persistent adversary, ironically, such as the TAO. By far his most important point for any defender is to know your network and know the assets that are actually deployed. Network mapping and asset identification is such a fundamental cybersecurity practice, but many organizations, not just critical infrastructure, still fail at adequately understanding their own layout. Additionally, he highlights how often exploitation is not accomplished through advanced techniques such as 0 days, but rather through publicly known, documented vulnerabilities and persistence. He further indicates that a solid defense should incorporate an active view into the network traffic. This implies that establishing baselines and then actually looking at the logs is an essential part of defense. In some respects, critical infrastructure can have an advantage over traditional networks because standard SCADA or ICS protocols, such as Modbus or DNP3 for example, use significantly different ports and can generate some relatively strange traffic in relation to more conventional web traffic. Rob Joyce goes on to offer numerous other fundamental cybersecurity techniques as a practical defense against modern threats. To see more of how a specific critical infrastructure location is dealing with the threats, Stefan Lüders of CERN has presented numerous times over the past few years, giving a detailed analysis of his experiences. Again, he often focuses on fundamental cybersecurity defense techniques, proactively looking for problems, and applying appropriate defense in depth around any technology that causes complications. He also highlights numerous other difficulties that critical infrastructure security engineers have to address as an industry. And a final defense that we'll address in this follow-up is information sharing. Recently, information threat sharing within communities has gained significant traction with the public and private sectors. Much of this effort could be traced back to Executive Order 13636, improving critical infrastructure cybersecurity, and the policies and guidelines that have come in its wake. Under this order, NIST developed a voluntary framework for improving critical infrastructure cybersecurity to provide a high-level guide. For a more specific look on how to actually implement the general practices from the NIST framework, the Department of Energy developed the Cybersecurity Capability Maturity Model, or C2M2. C2M2 focuses on providing specific details for improving cybersecurity capabilities for industries by providing both detailed insight and a framework for self-assessment. Information sharing has also been a large part of these efforts, and other private sector information sharing and analysis centers, or ISACs, share threat data to quickly identify vulnerabilities, threat patterns, and incident response lessons learned. The DoD recently expanded eligibility to the Cyber Incident Reporting and Threat Information Sharing Program, showing that information sharing has increasingly been used to mitigate the effects of cyber attacks. In summary, a solid cyber defense is established by implementing the fundamentals and having an active human security presence across the infrastructure. Additionally, understanding attackers' tactics, techniques, and procedures can also offer insight on how best to allocate limited resources. Information sharing is a relatively new effort by industries to create a pool of knowledge and awareness that strengthens the overall community. In the end, public and private, vendors and consumers, are all in this together and will need to continue to cooperate and communicate to best secure critical infrastructure technology. Found here is a list of all our sources. If you would like additional information on this topic, or you would like the CSIAC to follow up on a specific topic, feel free to contact us. Suggestions and feedback can be sent to csiac.org/discussion/digest-suggestions. Thank you for your time and enjoy your day.